Santa Cruz. My team is called Acatech, that's short for Academic Technology. We're very excited to present our project.
My name is Mohammed, and I'm the lead hardware engineer for this project.
Christopher, I'm the software engineer.
My name is Mohammed Garar, I'm the software engineer.
My name is Todd Ryan, I'm the hardware engineer.
And we're fortunate to be supervised by Dr. Sultan. Okay, so for the outline of our project, we're going to be focusing on the motivation, what motivated us to do this. We'll talk about the requirements and specifications. We'll go in depth with the system design and architecture. And then we'll talk about the deliverables. So our motivation. So over the past 200 years, the educational system has not changed very much. Today, the schooling system has yet to fully adapt itself to the potential of technology. Taking attendance is extremely slow and inefficient. Currently, teachers must go one by one, calling out each student by name in order to take attendance. Today's students are more unorganized than ever. There was a post by time.com that said that right now the attention span is at a decline. At about 8 seconds, adolescents have about 8 seconds to record their task or else they'll immediately forget, which is now slower than that of a goldfish, which has a 9-second attention span. Today there's difficulty for parents to know about their children. They must pick up their phones and contact the school, which obviously is inefficient because the person must get up, go find out information about the student status, and obviously that is slow. Teachers give way too many exams throughout the school year. I'm looking at you. This is because, the students must prove themselves multiple times a month to the teacher so that the teacher knows that they're learning the material. So what can schools improve on? We want schools to improve on an effective attendance system because today that should be automated. Schools can help improve student organization so that students can stay more on top of tasks and also evaluation. Student safety while at school because we can keep track of how much students are being recorded, how much they're so we want them to have a universal student management software because currently they're able to check grades and do little tasks like that, but we want parents and teachers to interact more with each other so that parents can easily check grades and check statistics so that the parent can easily interact and find better improvements for their student. So the question then becomes, how can we eliminate extra load while increasing student performance? Basically, we want to eliminate everything holding back schools because ultimately they're holding back the students.
So as Hansel was talking about, there are some areas the schools can improve on, namely their class attendance system and their organization of the students. So after market analysis, there are some existing products in the market that aim to fulfill these needs. Namely, it's the kinetic desk, which as you can see, it costs $3,500. It looks like this. The kinetic desk, it's a standing desk basically, and it's motorized, so you can control the operation of the desk, like its height, its width, even its width. So using the screen. Next is Flip-It 19 desk, and it starts from $1,600. It looks like this, and it's basically, it has no organizational tool, which is the main thing we're focusing on for our desk. It has basically a monitor which is incorporated into the desk itself, which can be hidden upon, hidden with a hinge, so there's more space. There's no other tech element. Furthermore, taking into account what Hansel was talking about, like how we're going to improve the school attendance system and organization. This is how our product is going to differentiate from the current market products. The current market products are more expensive. They are focused on a different market, so it's basically for a work environment. Standing desk is not a standing desk has no place in the school environment. It has no academic oriented organizational tools. There's no class attendance. There's no stuff such as note taking, which you can have handled. And it's a standalone product, so there's nothing more than the desk itself. For example, the Flip-It 19 desk, it's just a desk with a monitor inside. There's nothing more besides the desk. And there's no additional features. We're going to have bathroom queue, we're going to have class attendance. There's going to be a lot of software features. So keeping in mind our differences from the current market products in the products in the market, it's going. We're pursuing the following market requirements. It's going to be a simple attendance system. It's going to be plug and play. So once schools receive the desk themselves, they don't have to do anything to modify the desk. It's going to be easily. They're going to be able to use it as soon as they get them. So it's going to be modular. There's going to be hardware module, which is the desk itself, and then there's going to be software modules such as we can add more features. Right now we have a bathroom queue, we have a attendance, we have a parent, as we were talking about, a way to notify the parents if their child has arrived safely. It's going to be significantly low cost. The cheapest product in the market right now is $1,600. It's going to be high traffic capable, so a lot of desks can be used in tandem. And it's going to have a simple interface. Our main target audience is going to be elementary schools, so it needs to have a simple interface so the kids can operate the desk. And it's going to be privately stored in the school server. Almost all academic institutions nowadays have servers. Manhattan College has a server in RFC. So any communication within the classroom and within the school is, there's no chance that anybody can access that information.
So the system we will be creating will be one that's universal, that'll address all of these concerns. And the product we're creating is called AccuDesk. So basically, it's going to eliminate the time spent calling out each student one by one. It's going to automate attendance, and it will record all tasks and help students keep in track. So it will even record restroom times, even keeping track of your agenda, including homework assignments, upcoming exams, class schedule, and much more. So, number one, students will be able to seamlessly time in by scanning their ID on the desk. So, the second they come into class, they take their ID, scan on the desk, and their profile will be presented to them. Parents will receive an email alert upon student status update. So here's an example of me arriving to class on time, and my mother's very excited about that. So here's the subject line: Hansel has arrived to class on time. The body reads, "Hi, Mrs. Smith. Hansel has arrived to math class today on time at 9:04 a.m. The desk will recognize the ID and pull up the student's profile on an LCD display. Here's a representation of how it will look. The student can use the desk to keep track of assignments and request restroom breaks. So here's an example of how the student schedule will look along with the upcoming homework and the next test dates. The bottom image shows how the bathroom request system. We will have an automated bathroom queue system. So basically, you can request to use the bathroom, and your name will come up on the list. Students can be evaluated during class by questions set by the teacher. So before class or during class, the teacher can set questions to be presented on the student desk, and the student can answer based on what the question is. So for example, this question says, a pentagon has 5 sides. The student puts their mark through the buttons on the desk, and the desk will pick up the answer. This will help the students keep in mind of how much they're learning, and also show the teacher how much the students are learning.
In order to begin our class, we have to essentially translate the marketing requirements. We have to translate the marketing requirements into engineering requirements so that we're able to grasp them as engineering concepts that there's one thing the kids know how to do, is break everything. So we wanted to make sure that the internals are completely enclosed to reduce tampering by non-professionals. On the software side, we wanted to focus on 4 points. First point is that the system is high traffic capable, meaning that all the desks can be used in tandem, as Mohammed mentioned. So the system should be able to receive requests from multiple sources at the same time and still operate at a reasonable speed. Otherwise, it would essentially be a DDoS attack on itself. The second point is that the software should be efficient. The web application should be light enough to run on weak hardware so that we keep the cost low. The software should be secure and resilient, meaning all the vital information should be stored locally so that attackers from the outside have less chance to access that information. The server should be prepared to constantly run, to run calculations and statistics that run overnight. And a resiliency plan should be established in case that server does fail. And lastly, the system should be up to date at all times. So we want to have it so that the desks are all modifiable by one script, and that the system is easily upgraded to capture any security issues that may arise in the future.
Okay. So here's a high-level view from our system. We have 3 major components. We have a desk system, we have an SQL database server, and we have a web application. So first, the desk system. The desk system will have an LCD display, RFID scanner, and 2 buttons on the desk. This is going to be all hosted by the Raspberry Pi 3A Plus, and that is going to establish direct, seamless connectivity to the SQL server via Wi-Fi. The SQL server is going to store all the information regarding students and overall the whole school. The SQL server is going to be directly connected to the web application. And the web application is going to be the graphical user interface that the teacher is going to use certain options. So basically, the web application will be sending stuff like announcements, upcoming exams, homework, etc. to be stored on the database. The database will pull up, according to the student's profile, the information to be displayed on the LCD screen.
So we're going to have 2 simple interfaces, one for the teacher web app and one for the student web app. As you can see, the teacher is currently in the attendance tab. So it displays all the student attendance. So Hansel is present at 9:03 a.m. Chris is present, Mohammed is absent. So the next the teacher can do is initiate a queue. She's going to go into the queue tab and she's going to go to we're going to have a simple form where she can fill out the first name and the last name and contact the SQL server through Python class and then extract the information. And then she can send out send out a customized message to the parent that the name of the student is not present. Please contact the school for additional information. The student web app, it looks pretty simple. You just have to scan your ID on the RFID scanner we're going to have on the desk to enter the app. So these 2 web apps are going to be powered by the following technologies. It's going to be marked up using hypertext markup language. And it's going to be styled using cascading style sheets. So it's going to be really good to look at. We're going to add animations using JavaScript to make it more interactive. And it's going to be connected to the SQL server and the database through Python class. We were originally looking at PHP, but it's our backend engineer has more experience with Python class, so we thought we'd just go with that.
Alright, so basically, powering the whole system will be the backend structure. Backend is powered by Python because of its versatility, interacting with other frameworks and libraries. Connections to the SQL server and web application will be used through the backend. database is the hub of all data in the system, meaning all relevant information, sensitive or not, will be stored in the database. It's organized into tables of similar relevant information, so that's easy to access if the information is similar. It's going to be queried and updated hundreds of times a day because students will be checking in hundreds of times a day. It's important to keep it secure so that the information doesn't fall into the wrong hands. This is a basic example of what happens in the system when a student checks in. They scan their ID, and that sends a request to the server, symbolized by this blue circle. The request first hits this central application, which essentially manages all connections between software. That central application will add that check-in to the database, and the database will then send the requested information to the central application. The central application then sends